right, good morning, everyone. It's 9:15, so we're going to start the session this morning, 11B. The theme is vibration, and we have a couple of presenters. The first one is Andrei Ferraro. He has a first class in mechanical engineering degree, passionate about occupational health, and Andrei is leading the initiative for improving the hand and arm vibration standards with the latest technology. Okay, Andrei?
Yes, thank you, Gabriela. It's really great to be back at the BOHS, and this year I can actually finally say it. Our work in wearable technology over the past 6 years has now officially improved the standards for hand-arm vibration syndrome in the UK. The presentation is somewhat technical, but I'll try to keep your interest by describing my perspective of the UK HAVS regulatory system and the marketplace of technological solutions. The main aim of the presentation is to detail out the definition of keywords related to hand-arm vibration syndrome and present to you objectively the differences between measuring vibration exposure and monitoring vibration exposure. But first, just a brief history of hand-arm vibration standards and guidance in the UK. Hand-arm vibration syndrome was previously called vibration white finger. After the Industrial Revolution in the 18th century, but really more intensively in the 20th century, human beings started to use power tools to get the job done faster and more effective. In the 1970s, occupational hygienists from GKN started to get complaints from the workforce that their hands are numb, and some even saw their fingers go white during cold times. After investigations of the root cause, he called the phenomena vibration white finger. The International Standardization Organization were notified, and after about 30 years of research and analysis of the root cause, the first ISO standards were published in 2005. They were describing how to perform vibration measurement, how to calculate the weighting factor for the human hand, and what are the technological requirements to select the sensor technology that can generate data which is representative of vibration exposure. In the next 10 years after that, sensor technology and more specifically accelerometers made huge leaps in terms of diminishing in size. The sample rates improved and sensitivity improved massively. This was mainly due to the mobile revolution and the ambitions of the automotive industry. But HAVS research and technology development also benefited as a side effect. So in 2015, the ISO 5349 is revised to allow for accelerometers to be placed at the palm of the hand via handheld adapters. In the next couple of years after that, there was a boom of products and solutions for HAVS that tried to place the accelerometers as close to the hand as comfortably possible, and also some solutions that were nowhere near compliant, but they were claiming they were. This was the age of confusion in the UK HAVS market. So in 2017, the government decided to act and published a series of online pages and links to PDF documents, one of which actually clearly stating there is currently no wrist or glove-mounted device which measures vibration suitable for use in a vibration risk assessment. They were wise enough to use the word currently in the beginning of that sentence. And they used the word currently at the beginning of that sentence because they knew technology won't stop improving. So in 2022, they are now removing that statement and publishing new guidance that clearly defines how a compliant measurement is done, and also allow for more estimative solutions that only monitor the time of exposure. So you're probably wondering by this time, who is this guy? Why is he doing all this? My motivations are very simple. I really love physics, the physics of the human body, and technology. And I saw the opportunity to end the confusion and prevent hand-arm vibration syndrome in the next generation of workers. And I'm still trying to end the confusion, as you can see. I started getting into HAVS while I was working for Rolls-Royce Aerospace. I actually built my own prototypes and proved my theories through hard work and many experiments that almost got me HAVS on my right hand. I started getting into HAVS, like I said, while I was working there, but now I'm actually helping the country's largest infrastructure project, the HS2. I presented at the BOHS conference every year since 2018, and I won't stop until I get everyone in this country to focus on prevention and robust control measures based on accurate data. Okay, so let's get into it properly now. Here's a simple slide on what HAVS is. The symptoms are neurological at first, and then progress to vascular and musculoskeletal. Once you've reached advanced stages of poor blood circulation and loss of grip, these symptoms are pretty much irreversible. So you won't even be able to, hold a cup of tea on a cold morning or button your own shirt. So I want to go back to the basics quickly. It's very important that we both, we all speak the same language when it comes to the keywords on HAVS. Vibration is a physical phenomena which manifests in the time domain and in the frequency domain. In the time domain, vibration is called amplitude, and it's measured in meters per second squared. In simple words, amplitude is how much did you move your hand. And in the frequency domain, vibration is measured in hertz, and in simple words, frequency is how fast did you move your hand. So, okay, now for this next part, I need you to imagine the hand as the multiple mass spring damper systems coupled together. So it's a system formed of bones, vascular structures, muscles, and skin. So you can imagine one of those mass spring damper systems for each element and then couple them together and imagine them vibrating. Resonance is what causes hand-arm vibration syndrome. And resonance is harmful vibration that occurs when the vibrational frequency of the tool is the same as the natural frequency of the human hand. An average human hand like mine has around 20 natural frequency points between 6 Hz and 160 Hz. Every time you reach your natural frequency, your hand creates a mode shape. So have you ever seen sand create a mode shape on a vibrating flat surface or a speaker? That's a mode shape. It's really cool, but if you maintain the frequency of the human hand coupled system at the natural frequency, that's what causes hand-arm vibration syndrome, essentially. Now, like I said before, we've done numerous tests to understand the complexity of vibration exposure, and one thing is very clear. If you want to be accurate about the risk assessment, you need to measure vibration and also take into account other relevant parameters that are not yet standardized. And the not yet standardized, the keyword is yet. Parameters like grip force, hand orientation, the material of the vibrating handle, your human anthropometric data, how big you are as a human being, how big is your hand, all of those are influencing how you absorb vibration. Okay, so having said all that, and I promise this is my last technical slide, if you want to measure vibration and calculate exposure, this is the formulas you would need to use. And I'm only showing you this, so from this slide onwards I can say A8, and then everybody knows I'm saying daily vibration exposure measured in meters per second squared. So the revised version of the ISO 5349 in 2015 shows the compliant sensor placement for generating data representative of the vibration exposure. Representative data is generated by placing the accelerometer at or near the surface of the palm of the hand, either through a handheld adapter or fixed on the tool handle. So, very clearly, not at the wrist, not just anywhere on the tool, but clearly stated at the point of contact between the palm and the vibrating surface, either fixed by a screw or firmly handheld in place. So that's a measurement. Now, monitoring is something completely different, and you only need a way of keeping time for this. You can do it with a stopwatch, a kid's watch, or a very expensive watch. It doesn't matter. It's still just a crude estimation of vibration exposure. The daily vibration exposure A8 will increase constantly based on the time of exposure if you're using this methodology. If you choose this method to do your risk assessment, you're relying on data produced by the tool manufacturer, or in the best case scenario by an occupational hygienist with some good equipment. But still generalizing that measurement and discarding all of those relevant parameters that I've talked about on the slide with the vibrational mode shapes. So that's monitoring, and that's now clearly defined in the new HSE guidance. Okay, so this slide, I quite like this slide. This slide is an attempt to kind of summarize everything that I've said and just put it all into one slide. So if you tried all of the things that the ISO and the HSE mentioned to reduce vibration exposure, and you still didn't manage to eliminate the process or substitute the risk, then your next best bet is real-time prevention. So with solutions and technology available in the UK today, you can choose to take one of three separate paths available. The accurate path of measuring exposure, the traditional path of generalizing somewhat reliable measurements done in the past, or the estimative path of monitoring exposure. And whatever you decide to do, at the end, you'll base your risk assessment on that. And what comes out of that is either reliable control measures or hand-down vibration cases for your workforce. Just to be perfectly clear, I'm not a big fan of, and I'm not advocating for continuous measurements or continuous monitoring. The HSE is clearly not in favor of that, and that's very much stated in the new guidance. But you do have to do either measurements or monitoring to be able to do a risk assessment. So the focus of HAVS technology shall always be to formulate reliable control measures. Things like understanding and communicating the risk exposure, the risk of exposure, selecting the most appropriate tool for the job, doing job rotations to prevent overexposure, keeping your blood circulation in good shape, and continuously check how effective those control measures are with either measurements or monitoring. I do have other slides as well, but I think with 4 minutes left on the clock, I'll rather just turn it into a conversation with the people in the room and see if there's any questions, because there are other slides, but I would rather take questions now and address them with the next slides, if that makes sense.
Any questions right now, or should we? No? Do you want to go ahead?
Yes, sure. Yeah. So, just going completely off script now. We, like I said, they actually revised this now. So the statement that was made in 2017 on one PDF document was now taken away, and this is basically why, because tests were done and it was clearly shown that we can follow the weighting factor curve with the technology currently available. And I would like to just explain quickly. I have 3 minutes left, so I can do this. there's a clicker here as well. So you can see on this part of the graph, this is very low frequency, right? So 10 to the power of 0, that's 1, and 10 to the power of 1, that's 10. So between 1 and 10, this is pretty much where the resonance occurs. So, like I said before, a human hand like mine, an average human hand has about 20 resonance points between 1 hertz and between 6 hertz and 160 hertz. So this is why gloves don't actually work to dampen vibration, because what they do is you wear a glove that dampens vibration, it just brings the frequency down to exactly on the dangerous frequency. So you are more likely to experience those resonances because you're wearing a glove that is trying to dampen vibration. Does that make sense? So just just to have a few more slides on some operator feedback on the technology that we've done, and it's really with the technology available today, you can just rely on something that was built with the latest technology, and you can use it as a digital assistant to help the occupational health profession. And it's you always have either well-meaning critics for any kind of innovation, right? That kind of challenge the limitations of technology and understand its limitations, and then you have self-interested critics that have some kind of profit tied to the current ways, and they're not willing to accept the new way forward. Just some more examples of data and how measurements, if they're done correctly, can really show comparisons between people that work with vibration doing the same job. And if you do want to be very, very accurate, you can even understand when they have break times, how grip force is correlated to exposure and things like that. So there's some really cool things available right now. And with 23 seconds left, that's my presentation.
Right.